This is the beginning of the notes for Chapter 6, and we are going to be learning to write ionic formulas and then write the names if we are given a formula. Before we can start figuring out how to write these formulas, we need to spend just a moment talking about what makes a chemical bond. We've been talking about valence electrons and how you can end up with a positive and a negative charge. Well, that's where this all starts to come together, because you know that the opposite charges attract. So when a positively charged ion, a cation, as seen in this picture right here, gets close to a negatively charged ion, that force of mutual attraction will cause those two ions to come together and they will bond. This is just another view of the same thing. Ionic bonds are attractions between positive and negatively charged ions, attractions between cations and anions. And in ionic bonding, the main characteristic is that one of the elements completely gives up its electrons and the other element will completely gain the electron, and there's no sharing involved. And that is basically the definition of an ionic bond. Electrons being completely removed or gained. A word you are already very familiar with is a cation. And those elements in groups 1 and 2 and your transition metal, so everything that is a metal will form a cation and it will readily give up its electrons. The receivers of those electrons are the nonmetals. So as they take electrons, they become negative and are called anions. If you take a look at your periodic table, you should see something like this already written on it. We've talked about this quite a bit, how group 1 becomes positively charged and they have a +1 charge. They give up 1 electron. These elements in group 2, positive 2 charge. Aluminum is the element in group 3 that will always have a positive 3 charge. And then you can see over here our nonmetals having a -3, a -2, and a -1. And our noble gases aren't going to react because their outer shell is full. We're going to start working with what are called monoatomic ions, and mono just means one. So we're going to be looking at ions that come from a single atom. And they're going to come in 2 flavors. They're either going to be positively charged or negatively charged. So the basic rule is when you name these ions, you write their symbol, the letter associated with them, then you write the number of the charge, 1, 2, or 3, and then you're going to have a sign. So it's number, then sign. And then if it's losing electrons, becoming charged with a positive charge, you would add the word cation at the end if we were talking just about an ion. So we could start with calcium. Calcium is in group 2, so it has a positive 2 charge, so we just call it a calcium cation. But when you write it, you write the symbol, Ca, then the number, it was a 2, and then the plus. Potassium in group 1 would be a K+, and we typically do not write the 1, it is just understood. Just like in algebra, if you had a 1x, it's not very often that you write the 1. If you just have a plain old x, it's assumed to be a 1. So this is just a potassium cation. And then aluminum, with its 3+ charge, we would call it an aluminum cation. It's a little bit different for the anions who are becoming negative. But it's just one simple change, and it's you just say the name of the element and you add "ide" to the end. So we say the beginning part of the element and add "ide." For example, this is a fluorine atom. It's in group 7, so it's going to gain 1 electron, so we would call it fluoride. Okay, oxygen, take a look, it's in which group? group 2, so we write it as a 2 negative. We say the root name and add "ide." So oxygen would be called oxide. This is a chart just showing the main group elements. We've already talked about these and have shown their charges, but this shows at the bottom you can see all of these anions and how we put "ide" on the end. So fluoride, chloride, bromide, iodide, oxide, sulfide, nitride, and phosphide. This is also another picture that is just showing our ion. So our sodium, group 1, becomes an Na+. We call it sodium, and fluorine, with its negative sign, is a fluoride. All right, some practice on naming these ions, and you can just think them in your head, or you could write them down and check as we go along. So you're going to have to know the names of the elements and then know the rules for what you do if it's a cation. So see what you come up with for the names of these. We just call it barium, aluminum, and potassium. And if we were telling somebody what they were, we would say cation behind them so that we know that we're talking about an ion. Okay, this next row are the anions, so their names are going to be a little bit different. N3 minus, O2 minus, and F minus are nitride, oxide, and fluoride. In one row, take a look at these and decide how you would name them. Phosphide, sulfide, and chloride. Now that we know how to name the ions, we're going to start combining them together to make an ionic compound. And this is a really nice graphic that shows the steps that we are going to work through one step at a time. Step 1, identify the cation and anion. Then we're going to name the cation. Then we're going to name the anion with the "ide" on the end, and then we combine them together. So here we go. So name the cation, name the anion, stick IDE on the end. So if we have KCl, the cation is always first. So K is potassium, Cl is chlorine, but we have to drop the ending and replace it with IDE, so this becomes potassium chloride. Now try. Don't let the two confuse you. You just say the name of the cation and the name of the anion with the IDE. So hopefully you guessed sodium oxide. Another Li3N. Lithium nitride. Some more practice. So if I gave you NaCl and asked for the cation, you would write Na+. If I asked for the anion, Cl-, and then the name, sodium chloride. All right, now a couple for you to try. K2S. Decide what would be the cation, what would be the anion, and what would be the name. K+, S2-, and potassium sulfide. Next example, MgO. Mg2+, O2-, magnesium oxide, and CaI2. Calcium 2+, I-. Okay, for this next example, I actually have it written wrong. I don't want this to be an O. I want it to be an S. So go ahead and name it that way. So Al3 plus, and that 3 comes from the periodic table. S2 minus, again looking where it's at on the periodic table, and that would be aluminum sulfide. All right, just a little more practice. Name the compounds. Calcium oxide. Potassium bromide. Aluminum oxide. Magnesium chloride. All right, now you're probably thinking, okay, I've got it. So I want you to pause this video and go to eBackpack and open the assignment called Monoatomic Naming. And then there's a just a one-page worksheet that will give you some practice with this lesson. And then you'll come back. We have a few more slides to finish, and then there'll be a second worksheet for you to begin, but you will not be able to finish. All right, welcome back. Hopefully you were successful with that worksheet. Now that we know how to name, we're going to work the other direction and go from a name to a formula. So it's kind of a three-step process. From your name, you write your symbols for the ions side by side, and you always put your cation first. So in this example, it's aluminum oxide. Then I have no better way to explain this other than you have your charges written next to your individual ions, and you simply crisscross them and you drop the signs. And the charges which were at the top get written at the bottom. So this 2 minus goes crisscross and goes after the aluminum and becomes a subscript, and the 3 plus for the aluminum crisscrosses and goes behind the oxygen as just a regular 3. You ignore the signs. And then the last step is you look at them and see if you can reduce them. In this one we can't. It's as lowest common multiple there. So, but for example, if it was like a 6 and a 3, we would reduce it to a 3 and then just a 1. And just like as before, if it is a 1, we do not write it anything. You do not need to write a 1. So this takes a lot more practice and a little more work, and here I've helped you out a bit, which is this chart. So we're going to write the formulas and the names. So first we're going to write these side by side. So I'm going to have my Na, and it's a plus, and my Br, and it's a minus, and then I write it again. Oops, let's make it a Br, with a Br, and I crisscross those charges, so this becomes a 1, which I don't write. This Na crisscrosses, it becomes a 1 that I don't write. So the formula is NaBr, and that name, I'm going to leave that up to you. You can check it on the next page. Let's try one more, and then I'm going to have you try the rest of them, and then I'll put up the answers on the next slide. So we have an Na with a plus 1 and an S with a 2 minus. I don't know why I wrote a 1 there, just a 2 minus. So we write Na and S. We crisscross those charges. So the Na is a 1, that goes right here, but we don't write the 1. The S was a 2, that has to go here. So our formula is Na2S. And then you should name it. So spend a little time here, write these in your notebook, write down the formulas, write down the names, and then when you're ready, and pause the video, when you're ready, start it up again, and I'll show you the answers on the next slide. So here's the answers. How did you do? If you notice on this one, with the aluminum nitride, they were both 3s. So when you crisscrossed, we had Al3N3, but that can be reduced. So we just call it ALN. And if you had the 3s on there, that would be incorrect. Okay, let's practice some more. So lithium and oxygen. This time you're going to have to look at your periodic table, or use your brain to remember what are the formulas for these and what are their charges. So take a second and do that. So hopefully Li2O, the way that worked was lithium was a +1, oxygen was a 2-. We crisscrossed those, and that's where our Li got the 2 and the O simply had the 1. Oh, that animation didn't work. Calcium and sulfur, let's take a look at that. Ca was a 2+. Sulfur is a 2-. So when you crisscross, they're both 2s, but then we have to reduce, so we just get CaS. Try magnesium and phosphorus. Mg3P2. Potassium and chlorine. And hopefully you're pausing in between so you have time to think. It's just KCl. They are both 1 charges. Another one that I animated poorly. Sodium and nitrogen. So take a look at your periodic table. Na is a +1. Nitrogen is a 3-. Crisscross. Na3N. Beryllium and fluorine. BeF2. All right. Now, for more practice, I do want you to go to eBackpack, and the assignment that I want you to begin, but you will not be able to finish, is called binary ionic compounds. And I want you to try the top part and the middle part, but do not do the bottom at all. And if you come across any elements that are not main group, so if they're not in our first 2 columns or over in our nonmetals, anything that's in this transition section, they have special rules, and we will learn those tomorrow. So try part 1 and part 2 of binary ionic compounds, and I will see you guys tomorrow to answer any questions.